we're going to do 2, but we'll just do 1. So this is Unit 5, Lesson 2. Stay on the system of equations track, okay? I don't know. We'll see. Decent. Okay. So our exploration, we're going to determine the number of solutions to a system of linear equations. So determining the system, you want to see how many times they cross. You can have different numbers of solutions. So it's not always going to be 1. Could be 2. Could be none, just depending on what you're doing. Okay? So staying with this here, detailed below are the first 2 orders taken by each student and the total calculated by the student for each order. So Burger Shack, for the first order, Deja charges $28 for 4 burgers and 2 salads. For the second order, $34 for 6 burgers and a salad. So you can see what's our X and Y's here. What represents X? What represents Y? Yeah, burger and salad are the things that we're comparing. Okay, their prices, just like we did last time. What did we compare last time? You remember in our notes?
Tickets.
Kids and adults, yeah. Okay, good. Shelley charges $18 for a burger and 3 salads, $54 for 3 burgers and 9 salads. That's at Big's Burger. The Burger Haven, John charges $32 for 2 burgers and 4 salads, $42 for 3 burgers and 6 salads. So let X be the dollar cost of a burger and Y be the dollar cost of a salad. Write a system equation for each scenario. So what we're going to do is we are going to, let's move this down just a bit so I can see all of them. We're going to write each system here. Okay, so its cost is 28 equals 4x plus 2y. Next one for Burger Shack would be 34. 34 equals 6x plus y. Just one y, right? A salad. Burger Shack, yeah. Big Burgers next. $18 for Big Burgers. For 1 burger, which is x, 1x, and 3 salads. 3y. Any question on how I'm building these? Am I confusing anybody? Okay, next thing, $54 is equivalent to 3 burgers and 9 salads. Okay. The Burger Haven, John charges $32 for 2 burgers and 4 salads, $42 for 3 burgers and 6 salads, so 32 equals 2x plus 4y, and then 42 equals 3x and 6y. Okay, so we just built all this, the 2 system equations for each Burger Shack, or place. Can't say shack, I guess, since that's actually one. Okay, consider the equations of the Burger Shack. Write each question in terms of y. Using graph and calculator, determine the cost of the burger and cost of the salad. This is what you guys need to be good at, okay? Because this is where it's using your calculator, so this is a process, okay? So like, to me, there's not a lot of math here. The only math here is you have to do what to use your calculator?
Type it in.
You have to type it in, that's correct. But before that, Lauren? You have, Maddie, right? Y has to be by itself, okay? That's the only work you have to do. So this one's easy because y is already alone pretty much. We just have to move the 6x over. Okay, so for the first one, you're going to put this in your calculator, negative 6x plus 34. Order doesn't matter here. I just like to put my x. I like to put the slope form, okay, slope-intercept form. No problem. Okay, next thing, I got to solve for this one. So minus the 4x, so I get 2y equals negative 4x plus 28. I'm doing this one here. Divide 2. So the other one's going to be y equals negative 2x plus 14. Those are your 2 equations you're going to put in your calculator. Please try that now. So the first one in the y1, second one y2. Remember, to figure out the answer, you use which application? Second trace intersect, correct. What'd you guys get when they crossed? 5 and 4, okay? So you should have something going here. The other one's kind of twisted here. You got 5 for x, 4 for y. What does that represent?
$5 and $4.
That means that the Burger Shack charges $5 for a burger, $4 for a salad. Right?
Yes.
X equals
Okay,
5.
do the same thing for Big's Burgers. So do the same thing for the middle one there.
Wait, how do you get X5? Is that an intercept?
That's where they crossed. Yep. Okay, so guys, for B here, for part B or C, excuse me, we're on C or did B. For B, you should have got this twice. Some of you got 3/9, but 3/9 simplified is 1/3. Okay, so what happens is the lines are exactly the same, so we can't determine it. Okay, they're both the same line, therefore it's actually everywhere is a solution, which doesn't help us. Okay, so your line would be looking like this. It's the same line on top of itself. Obviously mine's not on top, but it's the same line on top of itself. What's that? Yeah. Well, no, that doesn't mean it costs the same, excuse me. Just means that by the information we've been given, we can't figure it out yet. Because the information we were given was the same comparison. So if right, it was the same sale. So if you look up there, it was x plus 3y is 18. If you times that top graph, see it on you guys right here. If you times all those by 3, you'll get the same exact thing you have below. So therefore, it's not a different equation. So technically, you have the same equation twice, which we don't have a system then. Does that make sense? Because to have a system, we need 2 different equations. Okay, so that was the problem with that one, okay? Okay, next one. The next one, if you get down here to D, you should get this. Y equals -1/2 x plus 8. And then y equals -1/2 x plus 7. What do you know about those two? You should know this from your test yesterday.
Parallel.
They're parallel. Good. That means they're not going to cross. So again, we have a solution. Okay. Correct. So what this does for us, guys, is this is setting us up to how many possible solutions there are. There's 3 possible for linear. Okay. The first answer was 1, right? We got 1. This one is none. What's this one? Not undefined, but good guess.
0.
Nope, because 0 is none, right? So that'd be the same as not crossing.
Everything.
No, what's another word for everything?
The R was the line for it.
That means everywhere, but I'm asking for the number of solutions. What's a number
Infinity.
Infinite. Good. Infinite solutions. The one here that's on top of each other, they hit each other infinitely because it's 2 lines on top of each other. So there's actually unlimited answers because the line is directly on the other line.
You and Curry
Okay.
in the main office.
This one, 0 solutions, infinite, 1, okay? That's what we're going through today. That's essentially the whole lesson, okay? So let's go. So here's your number of solutions. So let's do these here. So graph each system of equations. So we're just going to graph these quickly. I'm going to do these quickly, but I'm going to say that I do expect you at some point to be able to graph this quickly as well. Okay, what I'm talking about is, yeah, right here, +5. I should go 1, 2, 3, 4, 5. My slope's 1. Up 1 over 1. That's that line. You can count to 1 and count to 5. You're good. Slope's 1. It says graph each system of equations, state the number of solutions. The reason it doesn't matter how accurate I am is because I'm looking to see how many times it crosses. -x plus 1. Down 1 over 1. How many solutions? That's all I needed to do. What I did was, I went to +1. I went down 1 over 1. Drew a line through it. Because my slope's -1, right? Questions? Okay, so let's look at this one. What do you notice right off the bat? Parallel, 2x and 2x, and the -8, sure. Up 2 over 1. Here's this one. Then we have 6 have these two parallel lines. 0 solutions. Or no solutions, fine. Okay, and the next one we have to solve for y here. So if I solve for y, minus 6x, add the 4. Divide the negative 2. Right there. Oh, why does it 4? It's a 4, not a 9, sorry. Negative if can't read in your own writing. Minus 2. What do you notice? No. Same exact. 3x minus 2, 3x minus 2, they're the same line. Okay, so 3x minus 2 would be, starts here, up 3 over 1. It'd be this line on top of itself. So it'd be really bold, infinite. Those are your 3 options that we're going to put right down here for our little notes, our chart. Okay, going to hustle so we can get these guys out of here. All right, so this one here, number of solutions. 1, none. Graphical example, just draw a graphical example however you want where it crosses once. Slopes are different. Okay. For none, the lines are parallel. Infinitely. Same line on top of itself. Slopes are equal, and the y-intercept is equal. Put a little bracket here, same line. Sure, I'm not going to be able to stop though. Okay, go ahead and try A, B, and C here and see which one it is of the 3 options we just learned. Is it infinite? Is it none? Is it 1? Okay, try those 3 here. I'll pause it for a couple seconds, then we got one more example. It's done. Okay, so this one we have to get y by itself so we can see what it is compared to the y one they have. So when I do that, I minus 3x. Minus 3x. 5y equals negative 3x plus 15. Divide 5, divide 5. Y equals negative 3/5 x plus 3. Then I notice this one compared to this one, they have the same slope. They have different y-intercepts, so that would be our parallel example, so no solution here. Do the next one here. I'm going to minus the x. I think I might add the 4y, actually, might be quicker. So I'm going to go 4y equals x plus 8. Okay, 1/4 and 1/4. I have a 1/4 x plus 2 with a 1/4 x plus 2. No, they are parallel, but they have the same y-intercept on top. So this is infinite. Okay, and the last one here, got to solve for y on both of these. This one's just y equals negative 7x plus 12. This one's going to be
Junior class change.
divide by negative 6. So different slopes, different y-intercepts. This one is 1. Okay. All right. Okay, we'll do one more example. If you guys have to go, go ahead. Okay, so now we're talking about like zooming in so that we can actually see what's going on in the picture. So local high school, the Students' Council decided to sell sweaters to students. The cost of designing the sweaters included a fixed cost of $600 plus $5 per sweater. was we want to kind of highlight the important stuff. So that's pretty important. Let's not use red, though, because that's the information that develops my equation. The student council planned to sell sweaters for $25 each. So that's all they were going to do, just $25. They were going to have a fixed cost. Or, oh, I see, yeah. So that's fixed cost, okay. And they're represented by the following system of equations. Gotcha. So cost of sweaters is here. Revenue in sweaters is there. So what does revenue mean? Do you guys know in terms of business model? How much you bring in, right? And you always want your revenue to bring in enough to make a profit, right? So what this equation will do, this is going to let us know when we get profit. So when you start out, for example, if I sell one sweater, I'm going to have a negative, like I'm going to have $595 I owe, right? I'll be in the negative. So we want to this equation to help us figure out when your profit margin starts. Okay, we use system equations to determine that. Okay, so it's using graph and calculator to graph each equation. So go ahead and put these in your y1 and y2. Okay, and then we're going to sketch them. Okay, I'll sketch them here. I kind of know how to do it, I think. So 10 would be 50. So there's the cost. To make the sweaters, and I want to do 25N. Okay, so if you guys are with me, what is this point here, if you've got it yet? Has anybody got it yet? How much profit or less is made if you sell 20 sweaters? So let's look at this here. If I sell 20 sweaters, that right there tells me how much I'm going to make. This is your profit line, because that's how much you're making per sold sweater. This is your cost line, right? So if I do that, the difference between these 2 points is going to be the answer. So, for example, if I sell 20 sweaters, that makes $500. That makes sense? But that costs me $650. So I'm negative 150 in the hole still. Does that make sense? Okay, so 20 sweaters are sold. So you would lose, what did I say, 150? You'd lose $150. How about 50 sweaters? So if we go over here for 50, we look at 50. So 50, my cost of 50 looks like it's about $725. Okay, maybe a little bit more. Man, what's my, mine's off the charts. How much do you make then? What's 25 times 50? Say it again. Thanks. So 1250 is how much you'd make in revenue. Plug it into there. So what is 50? It's 250 minus 850. So your profit would be 400. Do you guys see what I did there? I just plugged in the number of sweaters in for our N, for number of sweaters. Okay? And this right here, this is cost. This is revenue. So revenue minus cost equals profit. Are we good? Okay. Okay. We said, oh, sorry, it's loss of 200. I was using my graph to estimate. You don't have to erase it. We still know it's a loss, and that's fine. All right, let's finish this out. We'll be done here. The break-even point. So what's the break-even point? Since I just moved my picture. Mine's not as easy to see, but where they cross is the break-even point. That point is where you don't make any profit, you break even. What is that point? Can you guys do the intersect method on that and tell me? How many sweaters? So I want to know how many X. What's the sweater count? 30, good, yep. What's Y say there? 750. So that means that $750 is your break-even point for revenue. Okay, good. Using graph calculator to determine the number of sweaters which must be sold in order to break even. We just did that. So it's 30, 750, 30. If all 850 students in the school purchase a sweater, how much profit would they make? Now here's the thing. How can you do this in your calculator? Instead of having to plug 850 in, how can we do it in the calculator? Do you guys remember? Trace 850, enter. Your graph will jump to it, right? Oh yeah, because we have 2 graphs in there. Sorry. So we have to take one out. That's okay. So let's do, we can still do, we'll just do the, what's 25 times 850? $20,250. Okay, and then what is 600 plus 5 times 850? So 5 times 850 is 4,000. Okay, so then can you subtract these now for me, Maddie? This would be our profit if everybody in the school bought a sweater. You get in the sweater business. Perfect. And that is correct. All right, that's all for lesson 2.